let's try out this numerical where it says differentiate tan inverse this with respect to tan inverse this. Alright. Now prior to getting into this numerical, these are few things which we have got to have it in our mind. Okay, I'll just pick those up one by one whenever required. Okay, alright, so you have got to differentiate this with respect to this. So obviously straight away we can't differentiate, so we have got to substitute this as some letter and substitute this as some letter. Let us choose letter as u and v. Conventionally we choose u and v, so let's choose u and v. Substitute this as u, so u is equal to tan inverse right. Now furthermore substitution, we have got to substitute x with something, alright, which sounds sensible. So let's substitute it with tan theta. Let x be equal to tan theta. Alright, so obviously theta would be equal to tan inverse x. Alright, okay, having substituted, now let us put in u. U is equal to tan inverse 1 plus tan square theta under root minus 1 over tan theta. Okay, now if you have formula here for 1 plus tan square theta, fine. Then what you would do, you would straight away write it as, but suppose you have forgotten the formula, then what? Then do we leave it at this stage? No. Identity, you know, right? So identity, so I have got to convert this in terms of tan. You know that sine over cos is tan, so I divide throughout by cos square theta. So this becomes tan square theta plus 1 is equal to sec square theta. Correct? Alright, so sec square theta, I got it. So see, I had to put in some time for getting this, but if you have got it by heart, straight away you jot it down there and you save some time. And that is what it is. All fight between time. It's all about time management. Alright, so this way. Okay, fine. So done. So now we can also write it as, now sec square theta, square root and square goes. Fine. Sec theta is just simple splitting of tan and this. So again LCM thing. Now I am sure you are okay with LCM. So cos goes there. So this is this part, numerator part. Alright, 1 over cos goes there, and cos is the denominator, cos theta is the denominator, and this is, so this cancels, so we end up with Can we move further? Now again see, formula if you have in your mind, done. But if not, then go back to this. So cos theta we know is equal to 1 minus 2 sine square theta by 2. So if I shift this that side, this side, so that's what we get in. Alright, so it is 2 sine square theta by 2 is equal to 1 minus cos theta. So we just substitute over here. So it is 2 sine theta. Okay. When we see this, it again strikes that there is some formula as sine 2 theta is equal to 2 sine theta cos theta. So obviously if I So if I divide this by 2, to divide this by 2, I have also to divide this by 2, getting in this. Alright, so that's what we want, and what we have over here is sine theta. So just substitute it there. Tan inverse, it is 2 sine square theta by 2, theta by 2, theta by 2 divided by this thing, 2 sine theta obviously one of this goes, this goes, this goes, one of sine square goes, and 2 goes, 2 goes, so we end up with u is equal to tan inverse sine theta by 2 divided by cos theta by 2. So we get so ultimately u is what? U comes out to be tan inverse of tan theta by 2. Alright, so this was our mission. So obviously this and this cancels, and we end up u to be equal to theta by 2. Alright, so this is what we got. Okay, so we got u is equal to theta by 2. Now let's substitute theta, that is tan inverse x 1 by 2 tan inverse x. So let's differentiate it now. So du by dx would be half here, and d by dx of tan inverse x. Tan inverse x already given over here, d by dx is 1 upon 1 plus x square. So let's just jot it down. So it is 2 into 1 upon 1 plus x square. So this is what is our du by dx. Alright, now let's proceed for v. So let's write here du by dx is equal to 1 upon 2 up into 1 this thing 1 plus x square. Right, now let's proceed for v. Alright, so let's substitute. Therefore theta is equal to sine inverse x. Let's substitute now. X is sine theta. Sine square theta. Alright. 1 minus sine square theta, 1 minus sine square theta is cos square theta out of identity. Now it is cos square theta, but root is there, so it disappears. So I am directly writing, instead of writing cos square theta and root above that, I am removing root because this was square, so it comes to this. And this is 1 minus 2 sine square theta. Now here also, now see, cos theta was, this was the formula. So if I multiply this theta and this theta by 2, it becomes cos 2 theta is equal to 1 minus 2 sine square theta. So it is 1 minus 2 sine square theta is equal to cos 2 theta. So I don't write this, I write cos 2 theta. 2 sine theta, cos theta already mentioned there. Alright, so we get tan inside. Not to forget, it is 2 theta. So this cancels. So our v comes to 2 theta. So I have got to do d by dx of this and got to convert sine theta, substitute this theta is equal to sine inverse x. Alright, so I substitute here sine inverse x. Already mentioned here, it is, this is the formula. This is the formula, right? So this would be, not to forget to write 2, which would be 2 into 1 upon a root of 1 minus x square, or rather it is 2 upon a root of 1 minus x square. Alright, so this is what is dv by dx. So du by dx is this, and dv by dx is 2 upon 1 minus x square a root. Alright, 1 minus x square the root. So this is then, what do I have to do? Just divide this by this. Having found du by dx and dv by dx, let's go ahead by doing du by dx and dv by dx. Let's go ahead with this, that is du by dx divided by dv by dx, which is equal to du by dx, it is 1 over 2 1 plus x square divided by 2 root of 1 minus x square. This goes up, this comes down. Alright, so it becomes 1 by 4, 2 into 2, 4, and this also comes down, that is 1 plus x square. Alright, and this goes up, that is, I remove this one and write here 1 minus x square root of it. So dx cancels, so this becomes du by dv, and this is what is differentiation of this with respect to this. Alright, so this is our final answer. Alright.